Alright, welcome to the video. First and foremost, let's talk about objects. That's what this chapter is mostly about. So, to discuss this, let me go ahead and just make a new little blank here. Alright, so what an object is it can be anything. Now, we've actually been dealing with objects the entire time, ever since Java 1 actually. We just haven't really been referring to them specifically as objects. Now what an object is anything I can create. I just give it some attributes and I can create a bunch of them. Let's use a very simple example here. Well, let's use a game example. It's not as simple, but you'll get the idea. Let's say in a shooter game, there's a bunch of zombies, right? You see them all running around the battlefield. You shoot one, it has health points, animations. You kill it, it dies. Well, it's got a couple of different things that are part of it. Now, first off, it has some attributes. And what an attribute is, or attribute, however you want to pronounce it, is things that represent what this thing is. So if we're talking about a zombie, it probably has some textures and some 3D models associated with it. Unless you're doing a 2D game, then it's pixels or sprites. It also probably has some sort of health, that sort of thing. And those have to be represented in integers, arrays, doubles, strings. Maybe it has a name. But all of those would basically be an attribute. Now, it typically is going to have some sort of constructor. And we'll get to what that is here in a minute. But a constructor creates this object, assigns the values to what they're supposed to be, that sort of thing. And lastly, it usually has some sort of methods. Now, what a method is, if you don't recall, is, some code we got put into a little separate area, and we can use it whenever we want. We just call it that name, maybe give it some values, and it does its thing. So in our zombie example, maybe he has an attack method. And in that method, he looks for the closest victim, and then he runs over there and attacks. And each attack does a certain amount of damage. He deals it off. Your character, its own object, receives that damage. Now, it probably has a method that interprets how much damage it takes. If it exceeds a certain amount, it dies. It'll play a death animation and it'll just lay on the screen inert. That's generally kind of how that would work. Of course, your personal character would probably have similar stuff. You probably have a name. If you were in an RPG or something, you'd have all kinds of stats, strength, intellect, maybe speed or constitution or stamina or whatever, luck, charisma. But all these attributes are part of your character. And if I make another character, they're going to have the exact same attributes. They might not look the same. The actual numbers may be different if I have two different characters, but the overall construction will be the same. So basically what an object is it's kind of a blueprint. So I say, this is what a character is. It has a name, it has all these stats. When I create it, I need to know its name and its class, and then I can set the stats and various other things. Methods, well, it can attack the people, it can talk, it has an inventory, that it can access probably with one of those methods, and that'd probably be an attribute. And then I can make a whole bunch of characters. Back to our zombie example, I can simply just, write up the code for one zombie. Every zombie you see on the screen isn't separate code. It's probably, one or two or maybe three different zombies, and, they just create 10 or 20 of that same zombie. A good simple way of thinking about this would be bullets. Whenever you're in a game and you're firing a bunch of bullets at people, one of those first-person shooters, right? What you end up getting is these little bullets travel across the screen, they hit something, they deal damage, whether it's the wall or whether it's a person or a monster or whatever, right? Now, they come from your gun, right? Now, they're not actually in your gun. All of it is code until you press the button that pulls the trigger. Now, once you do that, it fires an animation, and it accelerates that animation across the screen. And when it hits something, you know, whatever that happens to be, ding, it does damage or it kills it, depending on what it is. And that bullet disappears. If it hits the wall, usually you get some sort of like impact in a lot of these games. You'll see, like pew, and probably I want to pa. I do a little impact, just like that. And then I shoot another one, there's another little impact. Maybe it looks a little different, maybe it's bigger if I'm closer, that sort of thing. Now, if you ever notice in a game, typically speaking, that one little spot annoys me. Fine, I will fix you. There we go. Typically in the game, you can fire a whole bunch of shots at most of these games at the wall, but you can't actually destroy it. Because if you look closely, you'll note that the actual shot on the wall, it probably has some cracks and stuff in it, blah, blah, blah. But it's actually just a picture, like a 2D picture that's just placed on the wall to make it look like there's a hole there. But if you go around and kind of look at it, you see it's actually flat. Now you fire a couple of these, doon, 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 and then you'll notice the previous one might disappear. It disappears, and then another one appears. It disappears, another one appears. You actually can't, in most games, typically have just infinite bullets carving up whatever you want to in a wall. One reason for that is it takes up memory. Every one of those holes in the wall is actually an object by itself, too. We put the graphic on there. Whenever the bullet collides, pop, it puts that little image on the wall. Boop. Now, back to the bullets. Each bullet would be an object. So I fire the bullet from the gun, and this bullet has, maybe it has a caliber, so it does more damage, a certain damage integer attribute or something associated with it maybe. Maybe it has a speed, depending on the shot or the gun you're using. Maybe it goes faster across the battlefield from one place to another, which means it's going to animate and go from one point to the other faster. But it is an actual thing. Now you may have an array of bullets right here. Let's say in this case, for example, you do have bullets. Each little thing here is a bullet that's in your array. Now you fire, it fires that bullet out. This is kind of how it would, I guess you could say, would work in a game. There's a reason that, whenever you shoot a bullet, you create an object. But if you create too many objects, what do you think happens? If I just keep creating object after object after object, everything we make takes up memory. Now, if I fire bullets infinitely and don't take care of them, then what's going to end up happening is you're going to run out of memory. Your game's going to crash. So what typically is done is this. I fire a bullet. It's in this array of bullets I happen to have in memory. And it takes that first item and it launches it on the screen. I fire again, the second bullet gets accelerated, launched on the screen. The third, the fourth, the fifth. And I'm going to calculate how far those bullets are going to travel and how many bullets I need. So I might have like an array of this. 1, 2, 3, 4, 5, 6, 7. Maybe if I rapid fire 7 shots, that's the end of the distance I can see, right? So once it gets out of the distance, if it hasn't collided with anything, then I just deactivate it. Poof. And when I fire again, I'll fire this same bullet. I'll just, reactivate it back in my array and fire it out again. So I could sit there and shoot 1,000,000 bullets, but I'm actually only memory-wise dealing with like 7 or 10 or 20 or however many you need. And it saves a lot more memory. Your game won't crash. It'll run a lot smoother. It's kind of like in those games where you like shoot things and there are corpses and stuff on the ground. Well, if that's the case, you can't have infinite of those on the ground. Most games have little garbage collectors that will go and pick up those things and put them somewhere. Skyrim has an infamous room where all those things go before they dump them out and clear them, which I think you can command line to. But most games can't have them just laying on the ground. Once you leave for a certain amount of time, they just clean everything up and get rid of it. And most of the characters that you see, the enemies, are really just one object. They just create maybe an array of a couple of them, and they just keep reusing them over and over again. That's far more efficient. So let us see our first object. We're going to go ahead and make a very simple object, a rectangle. Pretty simple. Now to make a rectangle, we just have to decide what attributes make up a rectangle. What describes what a rectangle is? Well, a rectangle is obviously basically a square, but it's a little longer in one side than the other. This is a two-dimensional rectangle, so I have a length and I have a width. Those are my attributes. And that can be represented in doubles or integers, floats even, depending on how you want to do it. Well, those are the attributes I would make when I create it. I also need to know what can I do with this rectangle. Well, maybe if it was Minecraft, I could build things with it. Basically, just have an array of blocks. But since this is going to be like a 2D, mostly in memory kind of sort of thing, well, what can you do math-wise? You can find the area. Might be useful for some calculations. You can probably find the perimeter, like so. Those two things could be methods that I could use. Maybe I want to know the perimeter for something like maybe I'm laying out tiles or something in a Sims game or building game or something like that. You could also probably just display the length and the width. So maybe I just want to display. Just to display the length, just to display the width. And depending on what I want to do, I may want and depending on how these are set, I may specifically have other methods. We'll get more into it when we actually make it, but I may need a set length. And that would just be a display length, I guess. Or let's just say, actually, we'll leave display alone, and that'll just display everything for us. Set length, set width, and I'll explain why we may need those later. Get length, get width. Oop. We want to fix that. All right, so boop. Let's do that one more time. There we go. Get set width, get length. There we go. Now, actually I should make those lowercase too, but it doesn't matter. These are all the methods I could have for it. Now I may just have one or two, I may have 100, I may have an attack, I may have a magic spell, I may have, whatever drive, for example. Maybe I make a car, and the car has a lot of attributes, how much gas it has, what make and model, what graphics are on it. Maybe all the little parts have their own attributes, and that all affects how fast it goes, how it turns, what kind of tires it has. All this affects a bunch of stuff. And I have methods that calculate how much gas you burn, depending on how heavy or how fast you're going, or what type of gas even. We can make it as complicated as we want. But for now, let's keep it simple. Length and width. Now, I've already got a little method or a little program made here. So let's go ahead and go with that. So first and foremost, everything we've done up to this point, we've always done in this one file. But today, you're going to get a chance to make more files. When we're dealing with objects, we actually have more than one file. So I've got this intro objects here, and I'm going to go ahead and just right-click on default package. If you don't see that, it might be hidden, and you might have to open it up. But right-click, new Java class. And I'm just going to call this rectangle. That's it. New Java class, not package. And what you should end up getting is, there we go, rectangle. So I should have intro objects, which is my main, where I'm going to create all my objects. And this is the actual rectangle where I set it up and tell it what a rectangle is. So we need three things. First one, attributes, constructor, and methods. Those are generally the three things you'll have. Now, attribute, we've already talked about it. We have length and width, right? Now I can make this public, or I can make this private, and I'll explain the difference here. Public, and I don't need static or anything like that for this, but public int length. Private int width. So these two are my attributes. I could have more depending on what it is, but we're just going to have the two. Now constructor, always public, and actually, rectangle, let me fix that P. There we go. Now it's going to be the same name as whatever this is. So whatever you called this file when you made it, that's what this has got to be called. If I called it like rectangle1, it's not going to work. It's got to be the same name of the file. So, or the class. Rectangle constructor. Now this is what's called a default constructor. Basically all it's going to do is just say length equals 1, width equals 1. And notice they're green. Green typically means these are global variables. Now, I'm going to make another constructor. You don't necessarily have to have two, but in this case, I'm just doing it to show you. This one, I'm going to give some stuff. Int length, comma, int width. And the names don't have to be the same. I could just call this L and W. But it's the length and width I'm passing, so. And I'm going to say this dot length, capitalize. I should have lowercase those. That's too annoying. Let's go ahead and lowercase them. Length, width, length, width, length, width. And lowercase, uppercase are two different things. So this dot length equals length. This dot width equals width. Now let's explain a little bit about what this is. So this is what's called a default constructor. You run it, and it's just going to create it with a default setting. This would be like me creating a character, and it just defaults the name to Bob, and all the stats are 1. Just so I can play and test things, maybe. This, I specifically tell it what I want those numbers to be. So when it creates the rectangle, it's going to assign these values to that rectangle. So you'll notice that I have this, and then I just have regular length. Over here, we have length. And notice which one it highlights. The green one highlights this at the top. Now what this means is, essentially when you use this, we're talking about this object's variable, this global variable at the top. This right here is a local variable. So they're the same name, but you can actually have a local and a global variable that are the same name. But you differentiate them with this. Literally this. So this dot length. Now I alternatively could just do this here, and then I don't actually need this. That still works fine. But as far as things go, it's usually better to specify it's this object just in case, there's some error somewhere. It's probably slightly better programming to do it this way. But both ways technically work. I can't really tell you that this is absolutely not the best way or absolutely the right way. Either way technically works. This is just how I do it. So now we got methods. Let me fix my headset here before it cuts off. Let's see. There we go. Okay. So first and foremost, what methods did I proclaim I needed? Well, I needed length and width. Area, perimeter, display, set length, set width, get length, get width. Now, I'm just going to go ahead and make the display. Public, and I don't need static, so it's just going to be public void display. And all this is going to do is just simply print length plus length. And I could say this dot length, and it would be the same thing. There's only one length here, so width plus width. And you very well could say this dot length, this dot width if you wanted to. But it doesn't particularly matter for this in display. All right, so scroll on down. Take a quick crack at the next one. So the next one would be area, perimeter. I can make those return. I can make those just display. So we'll make the first one a basic display. Perimeter. And all this is going to do is just tell us what the perimeter is. So int p equals length times width. And then I just say perimeter is plus p. Boom. The next one I'll go ahead and make it return just so we can be a little different. Public, in this case, int get area is what I'm going to call it, because I'm trying to get the area, not just print them. So we're going to do the same thing. Int a equals, oh, whoops. Ha! I did the area up here instead. Oh, yeah. Okay, well, let's fix that. Length times width. And we'll come up here and just say it's actually length. I can say length times 2 plus width times 2. And that should work. The multiplication is going to happen first because of the plus. I could put some parentheses around it just to make sure if you're concerned. So 2 length, 2 width. You could also just alternatively just say, you know, length plus width, and you get the same result. All right, so return area. Or in this case, I might want to write out the whole thing, area. And I'll just leave p. But in get area. Now, with this, we have a couple of methods. We've got a couple of constructors up here. And we got our attributes. And notice field width can be final. We can ignore that. It's fine. It's because it's private. It has a little extra thing there. So let's first create a rectangle. We'll play with a couple of these, and I'll explain a little bit about what each of these things is for. So in order to create a rectangle, this is our basic blueprint. We go back to intro objects, and I'm going to create a rectangle. Here's how we do it. So the name of my file is rectangle. Rectangle R1 equals new rectangle. Now, this phrasing may seem kind of familiar to some of you. Perhaps something like that. That's because every time you made a scanner, you're actually building an object. Essentially just like what we're doing here. There's code just like this that lays out methods and all these things, and it allows us to use it. So when I make a new rectangle, I can say R1 dot. And notice things are going to pop up. This essentially creates the rectangle. Now, how big is my length going to be? Let's find out. If I just leave this blank, we do a little check. The length is 1, the width is 1. Okay. So the reason the length and width is 1 is because of this. Notice that it doesn't have anything. So which one of these matches that? This one. So I created a rectangle with a length and a width of 1. That's what that's going to do. Now if I specify, it will create it with that number. So if I go back, I can just make another rectangle. Rectangle R2 equals new rectangle. And this time, give it some numbers. 10, that's the length. 5's the width. And then I can display R2.display. And you'll see, well, there's the length and width of my second one. There's the length and width of my first one. Now what I've done here is I've created 2 completely separate objects with that one blueprint. So effectively, I made one rectangle. Yeah, let's move the other way. There you go. Boop. And I made a second. Boop. And of course, we've got, 1 and 1, and I've got 10 and 5 for the other. So I've got two completely separate rectangles. If I gave them names and stuff, I would have those attributes too. These are not to scale, obviously. But these are the two rectangles that I've created with their attributes. When I display the perimeter here, I would get 4. If I displayed the perimeter here, I would obviously get, 10 plus 10 is 20 plus another 10 is 30. So let's just do a quick little test drive there. R1 dot, and notice when I hit dot, we have display, we have get area, we have perimeter. Some of these things we are just kind of built into objects, but this one is something we specifically wrote. R2 dot perimeter. And I can just click on it. And we should see, well, the perimeter is 4, the perimeter is 30. I believe that's what I said, right? Now, here's where this public and private come into play. Public int basically means anything can access this. Anything in this class, anything outside this class. Private means only this class here can access that. So if I come back here and I try to say, r1 dot length, and I say equals 99. Let's move that up some. Guess what? Now r1's length is 99. So I can directly change that. Now, if I try to go to r1.width and set it equal to, 8 or something, it's going to tell me width has private access only. So I'm only allowed to access this inside the class. So you can't actually access the width, but you can access this one, the length, because it's public. So the difference is, sometimes it's nice to be able to change that whenever you want, but ideally you don't want that. The reason for this is, again, the nice thing is everybody can access it, but the negative thing is everyone can access it. If I had Mario's height as a public global variable and they could just change it whenever they want, you're going to break your entire game. Same is true for any other program. I only want anyone to be able to access this or change it or do whatever with my permission. So what I can do is if it's private, I can go down and I can make some set and get methods. So a set method allows me to make a change. And I'm just going to make a simple public, in this case, I could make this void set, which one was that, width? Set width. And I give it an int width. And all this is going to do, I could put in some if statements to make sure it's within a certain range. I'm not going to bother with that, but width equals width. Maybe I put a little print statement here, if it's not within 0, 1 and 100 or whatever, it's not allowed. And then I could make this a Boolean, which would return false if they tried to do that. But this gives them a way to actually make that change. Now, of course, I'm just allowing them to make it regardless of what the number is. You'd want to put some constraints in there. That's what this is kind of for. Now, you noticed before I can't actually get that value, right? So I may want public int get width, a method that will allow me to access that. Return width. Or I could say this dot width, it would be the same. But this allows me to actually get that value. So if I go back to my intro objects, I've got my set, I've got my get now. There we go. So even though I can't do this, I can now do this, r1 dot set width. And I can set the width to 8. And that will allow me to change it. Like so. Now, of course, again, I would put in constraints so they don't exceed certain sizes or numbers. Wouldn't want anyone breaking my program. That's what this is for. So ideally, you would want all your variables to be private. Now, if you don't say what they are, then they're private, or I'm sorry, they're public by default. So if I come over here, it's not going to complain because the link is public. I have to specify if I want it private. And if I go in here and say this is now private, then I'm going to immediately get some broken code because I can't directly access that. Public. Sometimes public's not bad if you just want to play with it, but you can make methods to do that too if you make it private. So, and if I want to get it, the width is plus r1 dot get width. And I don't think I ran the get area, but we'll check that in a second. There it is, the width is 8. And we'll just run both of these. I think, area for R1 plus R1 dot get area. Since that's a return, I have to have it either stored into a variable, int GA equals R2 dot get area. And I can just do the same thing, area for R2 plus GA. So I can do this one of two ways. Either variable, save it, and do it this way. And this allows me to actually use it in other places, not just display it. This only displays it, which kind of defeats the purpose, but there you go. R1 and R2. That is your basic primer on objects. And again, you could put this into anything you want. From a person, from a character, from an animal, from a you just have to think what attributes describe them and what actions can they do, what methods do they need. Maybe they can run, maybe they can jump. You would need a method, essentially, to describe those activities and make them do it. And of course, AI and all that stuff would be a little bit different, but you kind of hopefully get the idea. And now, with this rectangle created, I can actually go a little bit further if I wanted to, and I can do this. Ta-da! Oh. Equals new rectangle 5, which we'll get into later. But you can actually make arrays of those objects. I can make an array of cars. I could make an array of rectangles in this case. There are some little bit difficulties. This video's already gone a little bit long, so we'll talk about that in the next one. As always, if you have any questions or problems, let me know. Either in the comments or come see me directly.